So today we're going to talk about angles. Did segments last time, and so now we'll continue to build on these different geometric figures. So we'll talk about measuring and classifying angles. A lot of this stuff you should already be aware of, right? So first and foremost, an angle by definition, two rays that share a common endpoint. I'm going to forget the rest of this definition because the rays can lie on the same line. But that's the definition of an angle. But it's two rays that share a common endpoint. So down here, we've got ray AB and ray AC, and they're sharing A, and you get an angle when that happens. Okay. The common endpoint is called a vertex. As a matter of fact, any corner in geometry from here on out is going to be called a vertex. And the rays are going to be called sides. Those are the sides of the angles. And so in this particular angle, the vertex is point A. It's just a point, so we can list it as just a point. The sides are rays, will forever be rays, even if we choose in a diagram to cut those arrows off. We understand that there really is a ray there that's creating that angle, right? So we need to name them as rays. Ray AB, ray AC. Okay? When we name an angle, the idea is to use three letters with the vertex in the middle. The idea is that we should be able to start at a point and trace the angle without backtracking. So if I start here at B, then I can name points so that I'm tracing the angle. So to trace the angle, I go from B to A to C. So angle BAC would be one way to do this. Or we could start at C and go angle CAB. And we use an angle symbol there in front because without a symbol, three letters can also name a plane. So we get kind of an area where we can get a little confused as to what we're talking about. So we can do that. What we don't want to do is start with the vertex, because in order to name starting with the vertex, we have to go like up to this side and then backtracking over to this side. So we don't want to do that, right? So the vertex should always be in the middle. Or we could just use the vertex letter. So again, we could call this angle BAC or angle CAB. Or if there are no other angles using that vertex at that time, we could just say angle A. Okay? I will throw in here, sometimes we have enough angles in a picture that it becomes easier to just throw numbers inside the angle. And so we could call this angle 1 as well, as long as there's a 1 in there, or 2 or 3 or 4, whatever number there is. Okay? At some point, we'll start using numbers to name those angles. Okay? So that's how we're going to name our angles. All right. My favorite kind of angles are the angles that are used to create golf club, the heads of golf clubs, right? Golf club heads. Every iron and even the woods, the drivers and whatnot, are all set at an angle with the vertical. And so some clubs are called, had names like pitch and wedge and sand wedge, and sometimes they're just using the angles, a 52-degree or 56-degree wedge. Right? So anyway, just some places that we use angles. So practice naming some angles here. On the left-hand side, I'll walk through this with you. There are lots of angles here, right? Matter of fact, there are 3. Can you find them? 1, 2, and then this big guy here. So let's go through and name them, right? One of them, this guy right here, we'd call angle HIJ. This guy here we could call angle JIK, or we can always go the other way, JIH or KIJ. And then the big guy we'd name angle HIK. Okay? What we couldn't do is just say angle I. there are way too many angles at that vertex to try to just use the vertex to name the angle. Okay? So we don't want to do that. All right. So try the right-hand side. Name all the angles you possibly can. You can start the video up, and we'll walk through all the angles together. All right. Did you find angle CBA? That's this guy right here. Did you find angle CBD? That's this guy right here. How about angle ABD? That's this guy right here. How about angle BDA, which is this guy right here? Which, if you also just named angle D, that would be okay. There's only one angle there, right? Did you also find angle DAB, which is this guy right there? Which, again, you could just call angle A if you wanted to. You couldn't just say angle B. There are too many angles there at B. All right? All right. Next, angles do have measures, and we measure angles in degrees. As you progress into pre-calculus or trig stats, you'll talk about radians, measuring angles in radians. But for us, we're going to keep everything in degrees, keep it simple. And to find that measure, we use a protractor, just like we use a ruler to find the measure of a segment, right? So, protractor. Need some practice working a protractor. To measure an angle with a protractor, you want to put the flat side of the protractor down on top of one of the sides of the angle, right? So this guy right here. And then you want to line up the vertex in the center of that protractor. Now normally there's an arrow or a little circle that represents the center of that protractor, so that you want to make sure that you put the vertex on that thing. Line up this side with the straight part, the straight line on the protractor. And then, of course, we just use the other side, and where it hits the top of the protractor is the measure that we use. Okay? There are two sets of numbers that we can choose from in terms of figuring out what the measure is. And so what I would tell you is this. If the angle opens up from the right, in other words, if it opens up like this, if all of the interior points, or the points on the inside of the angle, are over here on the right-hand side, then you'd want to use the set of numbers where 0 is on the right-hand side, so like down here. So for this protractor, to measure this angle, I would use the bottom numbers. If this thing were to be turned around, and all of your interior angles were on the left side, like these, then so for example, I wanted to measure this angle, then I would want to go from, use the numbers where 0 is on the left-hand side. So 0 would be right here. We would use the top numbers. Okay? So anyway, this angle is opening up from the right. So we're going to use those bottom numbers. And so we get to 100, and just past 100, and then go to the tick mark there. You see that it's 105 degrees. Okay? Now that we know how to measure an angle, and when we have the measure of an angle, we can use that to help us classify the angles, right? If an angle measure is less than 90 degrees, right? There's a miter saw. Miter saws use angles all the time. But anyway, if an angle is less than 90 degrees, we call that acute. If an angle is 90 degrees, that's a right angle. And we'll talk about this a little bit, where this box in the angle says that it's a right angle. If an angle is bigger than 90 degrees, we call it an obtuse angle. And if the angle is 180 degrees, like two opposite rays where they form a line, then we call that a straight angle, right? A straight angle. We can use that idea also to help us figure out which set of numbers to use on a protractor. If an angle is definitely obtuse, like this guy, or for instance like this guy, then use the set of numbers that give you an angle measure bigger than 90 degrees, right? Use some common sense. And so on and so forth, all right? All right, so you've got a set of angles there in your notes, most of which look the same up here on the screen. but I think this first one might be a little bit different. Go ahead, stop the video, and find those angle measures, and then classify it, start it back up. We'll go through all of these and make sure that you're getting the right classification and the right angle measure. All right, did you find the first angle in your notes to be about 20 degrees? I believe that's what we came up with before. It's somewhere close, 20, 21, 22, 19 degrees would be close enough. And we call that an acute angle, of course. This next guy is the same as your notes. Did you find this angle to be 130 degrees? Hopefully you did. 130 degree angle means that this angle is obtuse. This next angle, shouldn't even need to measure it, right? But it is going to be 180 degrees because it's a straight angle. It makes a straight line. These are formed by two opposite rays. But when you measure it, that's what it would look like, right? The sides would just sit along the line, the straight line on the protractor. And there it doesn't matter which set of numbers you use. The next number down here is 180. The next number down here is 180. So 180 degrees straight angle. And then this guy, end up being 90 degrees, right? It's a right angle. So straight angles we can assume because in a computer-generated picture, we can tell if a line is straight or not. So we can assume that straight angles are there and they're 180 degrees. We cannot assume that angles are right angles just because of how it looks. I could draw you a 91 degree angle, which is not a right angle, it's obtuse, but it looks like a right angle. So we can't just say, well, it looks like 90 degrees. We have to know some information before we get to call it a right angle. We'd have to measure it and know that it's 90 degrees, or we could put this box, remember I mentioned before, this box in the angle, and that would tell you that it's a right angle as well, right? So just can't assume, we have to know for sure. All right. Now, that gets us to, since angles have measures, numerical measures, we can add numbers together, so we're going to add angles together in the form of the angle addition postulate. And so your definition or your postulate here basically says, if P is in the interior of angle RST, then the measure of angle RST is equal to the sum of the measures of angle RSP and PST. In other words, if two angles are adjacent if they share a side, and so these two smaller angles, angles RSP and angle TSP, are adjacent, they're sharing that side, and they form a bigger angle RST. If that's the case, then we can measure and we can add the measure of angle RSP to the measure of angle TSP, that's what we see here. And when we add that, then that should equal the measure of the bigger angle RST, right? So hopefully that makes a lot of sense, but we want to make sure that the angles are touching, they are adjacent, they are sharing a side, and then we'll add them together to form a bigger angle. Okay? And so, again, like the segment addition postulate, we want to write out the angle addition postulate with the angles, with the naming of the angles in the measure, and then fill in what we know to see what algebra we need to use. Also, before I forget, to write the angle. So we name an angle like angle RST. That's how we name it. If we want to talk about the measure, the numerical measure, we do need to switch over to the world of numbers in geometry and put the M in front and call this the measure of angle RST. Okay? That's talking about, those two names are talking about two different things. Angle RST is the actual physical angle. M of angle RST is the numerical measure of that angle. Right? There's a difference. All right. How can we use the angle addition postulate? Well, in the first picture here on the left, we see that the measure of angle WXZ is 145 degrees. And we've got expressions for angles WXY and angle YXZ. So because WXY and YXZ are adjacent, they share this side, then we know that the measure of angle WXY plus the measure of angle YXZ must be equal to the measure of angle WXZ. And so now we fill in what we know, right? WXY is represented by that expression, 2x plus 10. YXZ is represented by that expression, 4x minus 3. And the measure of angle WXZ is 145 degrees. So there's your equation. And so we're back in algebra land. We can go ahead and solve this guy. Combine your like terms. Subtract 7. Divide by 6. And x is 23. But we don't want to stop at x. We need to find the angle measures. So go ahead and plug 23 back in. And you get 56 degrees here. And when you do this, plug it in 23 for x down here, you get 89 degrees here. And when you find those two angle measures and do them separately, add them up. Make sure they add to 145. If they don't, then there's a problem. You need to go fix it. Okay? But these guys do add to 145 degrees, so we're in good shape. 56 and 89 degrees are the angle measures we're looking for. Okay? All right, use that to help you solve the example on the right. Stop the video, then you can start it back up and make sure that you've done it correctly. All right, did you get 52 degrees for angle EFH and 38 degrees for the measure of angle GFH? Right, so we're going to add those two smaller angles together, 3x plus 4 and the 2x plus 6, and set it equal to 90. Why 90? Because we were told the angle EFG is a right angle. Right, and solve that equation. X should be 16. And then plug the 16 back in for x. Now I knew that it was right because when I got the two angle measures, 52 and 38, they do add to 90. So I was in good shape. Okay? If you're not getting that, it's still a little confusing, then make sure you get in here and get some help right away. Okay? All right. Since angles have measures, then it introduces the idea that angles could also be congruent, right? So if two angles are going to be congruent, then, and I'll put all these up here, then they're going to have the same measure, right? Just like segments, they have the same measure, they're going to be congruent. So again, geometry existing in two different worlds, one the numerical world and the other one the figure world. In the numerical world, if two angles have the same measure, then we can write an equality statement, which is this: the measure of angle A equals the measure of angle B. Since the measures are equal, then we can switch over to the figure world and say that angle A is congruent to angle B and write a congruence statement. Okay? There, again, two statements there that do mean the same thing. They're just written differently, right? They mean the same thing, they're just written differently. Now, in a diagram, angles are going to be congruent. We show that, and we do that just like segments. Segments, we have tick marks, and so we'll use tick marks for that. In angles, we'll use arcs. Right, so those arcs mean that angle A and angle B are congruent as well. And we can use multiple arcs if we need to, and we will when we have multiple sets of angles in a diagram that are congruent. So those arcs will tell us that those angles are congruent. All right? Now, when we have congruent angles, then that introduces the idea of being able to bisect an angle. Just like we're bisecting a segment, we cut a segment into two congruent pieces, and when we bisect an angle, we're doing the same thing. An angle bisector is a ray that does it, and a ray is the only shape that can bisect an angle, right? It's a ray that divides an angle into two congruent angles, okay? So that in these examples, when we're told that ray YW bisects angle XYZ, then we should be able to draw these diagrams without them being given to us. We would simply draw angle XYZ and then draw ray YW. Okay? And that means, and so since ray YW is bisecting angle XYZ, that means that these two smaller pieces here are congruent. And so we can go ahead and mark that with tick marks. Or I'm sorry, not with tick marks, but with arcs. Okay? Now, we have some options here, just like we did for segment bisectors where we had congruent pieces. We might want to set those pieces equal to each other, or we might want to add them up and set them equal to the bigger angle. Well, we want to find the measure of angle XYZ. That involves the bigger angle. So to find the measure of angle XYZ, we'd have to add the measure of angle XYW and the measure of angle ZYW. We're told that angle XYW is 28 degrees, which is this angle right here. Since that angle is 28 degrees, so is ZYW. So now we can fill in what we know. If we want to find the measure of angle XYZ, we'd make this 28 plus 28, which is 56 degrees. Okay? But using the idea that those two pieces are congruent. Right? The second example here, check that out. Again, YW is bisecting angle XYZ. So what exactly does that mean? Right? Remember that means that it's cutting this angle, bigger angle up into two congruent pieces like this. And now we're told that angle XYZ is 51 degrees. Well, if this whole thing is 51 degrees, then WYZ would have to be half of that, right? We would have to cut that in half because these two pieces are exactly the same size. So 25.5 degrees, 25.5 degrees, that's what we'd be looking for. Okay? All right, and then that leads us to this last example. Take a look at this last example. See if you can't figure out how to set it up to help you find the measure of angle XYW and the measure of angle WYZ. Take a second, stop the video, try to work it out, and then I'll show you the way it should have been worked out. Okay. So still, YW is an angle bisector. So we're going to mark these guys congruent. And since we see that XYW and WYZ are going to be the same, so we can just set them equal to each other. X plus 1 equals 2x minus 1. Solve that. X is 2. And when you plug 2 in, you should get 3 degrees for both of those angles. All right? All right, well, that's it. Hopefully that makes enough sense about angles. If there are any questions or curiosities or concerns or any confusions, make sure you get in here during STAR and we'll figure all that out. Okay? Homework out in Canvas. Make sure you have it done by next time.